let's talk first of all about yesterday's lab. I'm going to just go over all the questions real quick. Is that okay?
Yeah.
So we can check them. They were pretty simple. Can you identify the solid? Yeah, it's copper. Same stuff we had the day before. What would happen if you heated the solid that you recovered in this experiment? What would happen?
Turn into copper oxide.
Right. Some of it would, right? Not all of it. That's what we found. Some of it's going to turn back into copper oxide. So some would form CuO, copper oxide. How do you expect the total mass of the solid recovery experiment 6.7 and 6.9 to compare to the initial mass that you heated at 6.6? How would it compare?
Stay the same.
So it would be the same. We start with 1 gram, we would end with 1 gram. So I'm just going to put the same. Okay? So that should have been an easy 10 points. I don't have a lab to do today, but we will do one on Tuesday. Now I'm in the process of setting it all up. It's kind of a big one. All right?
Is it calcium chloride table salt?
No, that's sodium chloride.
Sodium chloride.
Yep.
Calcium chloride is like ice melt, isn't it?
It could be.
This has ice
There's-
melt in it. Smart water.
Is it? Good. All right, so
I'm
let's
drinking ice milk.
go over the worksheet. I know some of these were pretty simple, but I'm going to go over all of it because I'm going to video it. Is that all right with you guys? I can do a different hour if you want me to. The first one says write the balanced equation for this. I think it's 2 and 3 on that one, right? And then this one is already balanced. This one is 2 and 2. If you have questions, stop me. Number 2, why must you balance an equation to describe correctly what happens in a chemical reaction? The law of conservation of mass. Says the elements. Maybe I'm going to change that. I'm going to say the number of elements. The number of elements you start with, comma, you should end with. So if we start with 2 nitrogen atoms, we should end with 2 nitrogen atoms because we can't create and we can't lose atoms. All right? Number 3, what does the 4H2O tell you about the number of molecules? Well, it means we have 4 molecules of H2O. What does it tell you about the number of atoms of each element? So for the second part, we have 4 times the H's and O's, what's ever in the formula, okay? So we have 8 H's, because it's 4 times H2, and we have 4 O's. Number 4 we didn't do. Number 5, I'm going to have to move this up 4. Does adding coefficients to a chemical equation, I'll leave that on there so you can get it written down. Does adding coefficients to a chemical equation disobey the law of definite proportions? No, comma, it doesn't change the formula. So 4 H2O means we have 4 waters, okay? Over to the back. So Lucas, you got all this down? You got the equation memorized?
Yeah,
And you know exactly what you put on it, so.
I don't know where my paper is.
So what one did we do yesterday? Number 5, was that the one we did in here?
Yeah.
Okay, so let's go through the other ones real quick. On this one, I think it's a 2 here and a 2 there, is that right?
Yeah.
On number 2, it's 3 and 3.
Yeah.
Number 3 is 3, 2, 6.
Yo-yo.
Number 4 is 4. 2. Number 5, we did. So let me move this up so we can see 6 through 10. Number 6. This is 2, and that's 2. Number 7. Okay, we've got 2 O's. We need to have 2 O's over here. We've got 2 H's, 3 H's, 4 H's. We got to put a 2 in front of that. Does that balance it? Okay, so number 5 or number 8 is a little bit more complicated. I'm going to talk my way through this one. We've got 1 FE and 2 FEs. So let's start by putting a 2 here. Okay, then we're going to change that here in a second. Now we've got 2 S's, so we'll put a 2 in front of the SO2. And we have 2 O's, but over here we have 7 O's. So we can't take anything times 2 to get to 7. So we have to make this an even number by doubling it. So we're going to make that, put a 2 in front of that, and that changes everything else, and now let's work our way backwards. So now we have 4 FEs, so this has to be 4. Now we have 4 S's, so this has to be 4. Now how many O's do we have total on this side? 14. You've got 2 times 3, which is 6, and 4 times 2, which is 8. So 6 plus 8 is 14. So we're going to put a 7 in front of that. Right? Number 9, 1P, 1P, 5 CLs. So we're going to put a 5 in front of that. 2 H's. On this side, we've got 3 8 H's. So we're going to put a 4 in front of that. And we've got 4 O's and 4 O's. And number 10, 2 C's, 2 C's, 6 H's. So if we put a 3 in front of that, that gets 6 H's. Now we have 1, 2, 3 O's. But over here we've got 4, 7 O's. The nice thing is we've got an odd number. We've got 1 right here. So we just need to get this to 6. We can do that by putting a 3 in front of it. Any questions? Okay. How many of you got every one of those right? A couple of you, good. Good. How many of you got most of them right?
The ones that I did.
All right. Most of them? The ones that you did? It's tough to get them right if you don't do them. All right, so on the next page, write this in. We're going to talk a little bit today about complete and incomplete reactions. For 6.8, you'll need to read pages 122 and 123 and answer number 19. 19 is really easy, okay? You don't even need to send me a picture of it.
So we're not submitting.
So don't turn anything.
Just type the answer,
Okay.
okay? I mean, you can send me a picture, but you'll just be wasting your time. Just type the answer. Addie, have you been waiting very long? I had it pulled up and I didn't see you sign on. I videoed my whole discussion of, what was it? The worksheet
Yeah.
and the lab from yesterday. So if you need to, you can watch that video. But you'll need to write or get it off of Canvas, the notes for 6.8, okay?